Nth root of a complex number. In previous lectures, we have seen how to find out the nth root of unity, and as well as we have seen how to find out the cubed root of unity. Okay, please watch the videos. Now in this lecture, we are going to discuss how to find out the nth root of a complex number. Okay, so let's consider a complex number is given as z is equals to x plus iy. Then that complex number has to be represented in the polar form as r times of cos theta plus I times of sin theta. So now after representing this, the question is asking us to find the nth root of the complex number z. Okay, nth root of the complex number z. So to find out this, we have to write this is as z power 1 by n. Okay, z power 1 by n, where before the classes, in previous classes, we have seen 1 power 1 by n, nth root of unity, but here the 1 is represented by a complex number z, where z has to be represented in the polar form r times of cos theta plus I sin theta. Then how to find out this? Now replace z with r times of cos theta plus I sin theta. Okay, then which is whole power 1 by n. Okay, now this can be written as r power 1 by n into cos theta plus I sin theta whole power 1 by n, and we know that for the theta can be expressed as multiple of 360 degrees. Then we can write generalize this nth root of the complex number as cos of 2k pi plus theta plus I times of sine of 2k pi plus theta. Just recall the concept what we have discussed in the previous lectures, that is the nth root of unity, that only we are making over here. So that means here we generalized, okay, here we generalized the given complex number. Okay, generalized the given complex number. Next, after generalizing the complex number, now apply the DeMoivre's theorem. Then what we get over here, cos theta plus I sin theta whole power n can be written as cos n theta plus I sin n theta, where here n is equals to 1 by n. Then we can write this is as cos 2k pi plus theta by n into 1 by n is nothing but we can write this as by n plus I sin 2k pi plus theta by n. Now here we applied the DeMoivre's theorem over here. By applying the DeMoivre's theorem, we can write in this manner. So where here k equals to, okay, here k equals to 0, 1, 2 and so on up to n minus 1 are to be taken. So now which is as nth root of a complex number z can be find out as r power n cos of 2k pi plus theta by n plus I sin 2k pi plus theta by n, where k has to be considered from 0 to n minus 1. This is the way of finding the nth root of a complex number. So the n roots, okay, we need to find the n roots of given complex number. For example, consider over here. So the question is asking us to find the, okay, value of, okay, find the value of I power, okay, find the value of I power 1 by 3. Okay, so that means here what he has given, how to find out the solution. So here given a complex number z is equals to I. Okay, we know that in the polar form how we can represent this is as where r is equals to compare with x plus iy. So I think we already know how to find out the z is equals to I. That means if it is x is equals to I, y, z is equals to x plus iy. So to write this in terms of cos theta plus I sine theta. Okay, then we can find that r is equals to square root of x square plus y square, where theta equals to, depending on the quadrant, generally it is taken as tan inverse of y by x. If it is in the first quadrant, directly it is tan inverse of y by x. Then substitute r and theta, then we will find out the complex number in the polar form. Okay, now how to represent z is equals to I? That means x is equals to 0, y is equals to 1, r is equals to, then x is equals to 0, y is r is equals to 1 only. Tan inverse of 1 by 0. Tan inverse of infinity means pi by 2. Then we can write this as z equals to, r is nothing but 1 into cos pi by 2 is 0 plus I times of sine pi by 2 is 1. Okay, then we obtain this. Okay, but here what is asking? I power 1 by 3. Okay, I power 1 by 3. So that means here z power 1 by 3. Okay, the concept is nth root, cubed root of the complex number I. So which is can be finded as, we represented in the polar form. Then we can write the z as cos pi by 2 plus I times of sine pi by 2 whole power 1 by 3. Now generalize. So how to generalize this? We have to generalize as cos of 2k pi plus pi by 2. Okay, so cos of 2k pi plus pi by 2 plus I sine of 2k pi plus pi by 2. Okay, this is the generalization of the given complex number power 1 by 3. Now apply the DeMoivre's theorem. So if apply the DeMoivre's theorem, now I power 1 by 3. Okay, now which is equals to cos, what we'll get over here, 2k pi, okay, into 1 by 3 means we can write it as 2k pi by 3 plus pi by 2 into 1 by 3, that means here it is pi by 6 plus I times of sine 2k pi plus pi by 2 into 1 by 3, and if we simplify over here, 2k pi by 3 plus pi by 6. Okay, pi by 6. So which is our required, what it is, I power 1 by 3, and here what is the k values has to be taken. Okay, the k values has to be taken as 0 to n minus 1. N is equals to 3 over here. That means 0, 1 and 2. N minus 1 means 2. So now if k is equals to, okay, if k is equals to 0, okay, if k is equals to 0, then we obtain the first root of the given I power 1 by 3. What is the root? First root is, okay, k is equals to 1 by 3. The first root we obtain, it is as cos, okay, cos k 2 k pi, k is equals to 0 means simply it is cos pi by 6 plus I times of sine pi by 6. So which is equals to cos 30. So root 3 by 2 plus I into 1 by 2. Okay, so which is the first root. And if k is equals to 1, and we obtain the second root, then what is the second root for the given I power 1 by 3? So we obtain it is as k is equals to 1, 2 pi by 3 plus pi by 6. Then we can simplify this cos of 5 pi by 6. Okay, cos of 5 pi by 6 plus I times of sine of 5 pi by 6. Then you can find the value over here. Then if k is equals to 2, then what is the third root? Nth root to have n roots. Okay, so here it have the n roots. What it is? Cos k is equals to 2. Okay, 4 pi by 3 plus pi by 6. Then we obtain this as 3 pi by 2 cos 3 pi by 2 plus I times of sine 3 pi by 2. Okay, so that means here the roots of I power is asking us to find the I power 1 by 3. So the solution, the values, that means the roots of this one is, simply we can write it as cos pi by 6 plus I sin pi by 6 as 6 pi by 6 is one root. Okay, next 6 5 pi by 6 cos theta plus I sin theta. So cos 5 pi by 6 plus I sin 5 pi by 6. that means cis 5 pi by 6, and another root is cis 3 pi by 2. These are the three roots of the complex number I power 1 by 3. So now we will understand the nth root of finding the nth root of a complex number with few more examples. The first thing he has given it is as 1 minus I root 3 whole power 1 by 3. Okay, that means which is in the form of z power 1 by n, where z is equals to 1 minus I root 3 and n is equals to, here it is 3. So now if z equals to, okay, z equals to 1 minus I root 3, then how to represent this z in terms of polar form, or times of cos theta plus I sin theta. So we can write this is as in the polar form as, so how do we write this is as in the polar form? R is equals to square root of 1 square plus root 3 whole square means 3. That means here we obtain R is equals to 3, and this is in the fourth quadrant. Okay, positive x, okay, real axis and imaginary. So that means what it is, 1 into minus root 3, that means I minus root 3 in fourth quadrant. In the fourth quadrant, theta equals to minus alpha, where alpha equals to, we can write this as tan inverse of imaginary root 3 by the real 1. So that means simply modulus we consider, that means alpha equals to pi by 3. Okay, alpha equals to 60 degrees, that means pi by 3, where the argument theta equals to minus alpha, that means it is minus pi by 3. I think you know the concept of how to find out the convert the given complex number in the x plus iy form into the modulus amplitude form, that means r times of cos theta plus I sin theta. Just please watch the video regarding this in the complex numbers playlist. Now coming to over here, 1 minus I root 3 whole power 1 by 3. Now the 1 minus I root 3 in the polar form can be written as, so how it can be written as, r equals to 2 into, okay, 2 into cos of, what it is, minus pi by 3. Okay, cos of minus pi by 3, okay, plus I into sine of minus pi by 3, minus pi by 3 whole power 1 by 3. So just before we have discussed that in the starting of this lecture, r times of cos theta plus I sin of sin theta whole power 1 by n can be written as 2 power 1 by 3. And now we have to generalize this one. Then how to generalize? For every 360 degrees the same value has to be obtained. Then cos 2k pi plus theta is nothing but minus pi by 3 over here, plus I times of sine 2k pi plus theta is nothing but minus pi by 3, and power 1 by 3. Okay, power 1 by 3. Okay, right. So this is okay, right. So now we can write this is as 2 power 1 by 3, and now apply the DeMoivre's theorem. So if we apply the DeMoivre's theorem, what we obtain over here, it is as, so what it is, so before that try to find out the generalize this one, what it is. If we take LCM, we can write this is as 6k minus 1 into pi by 3. Okay, now we are writing in the form of sine of, what it is, 6k minus 1 into pi by 3. Okay, so that means 2k pi minus pi by 3 can be written as 6k minus 1 pi by 3 and power 1 by 3. Now apply the DeMoivre's theorem. Now 2 power 1 by 3 into cos of, what it is then, 6k minus 1 pi by 3 into 1 by 3. So that means into 1 by 3 means directly we can write over here it is as pi by 9 plus I times of sine of 6k minus 1 into pi by 9. Okay, here we are applying the DeMoivre's theorem. So 1 by 3 is multiplied, pi by 3 into 1 by 3 is pi by 9. Okay, right. So finally we can write this is as, okay, what it is our requirement. So 1 minus I root 3 whole power 1 by 3 can be written as 2 power 1 by 3 cos theta plus I sin theta can be written as cis theta. Theta is nothing but here 6k minus 1 pi by 9, where k is equals to, here n is equals to 3, 0 to n minus 1, that means 0 comma 1 comma 2. This is our required solution for this one. Okay, if you substitute k is equals to 0, you will obtain cis of minus pi by 9. If k is equals to 1, what is 5 pi by 6, 5 pi by 9, k is equals to 2, cis what it is 11 pi by 9 or the solutions. Then the values of what is 1 minus I root 3 whole power 1 by 3 are 2 power 1 by 3 cis of 6k minus 1 pi by 9, where k is equals to 0, 1, 2. I think you understand how to solve the nth root of a complex number. Next, move for the next problem. The next one is minus I power 1 by 6. So minus I in the polar form can be written. I am directly writing over here. So minus I in the polar form I am writing this is as cos of minus pi by 2. That means cos of pi by 2 is 0 plus I sine of minus pi by 2. Okay. So which is nothing but 0 minus I, that means in the fourth quadrant it is minus pi by 2 minus I sine pi by 2. It is, we obtain this is as minus I. Okay, and the modulus is 1, r is equals to 1 over here. Now we can write this is as generalized as. So how to generalize this one is, we can generalize this as cos of 2k pi minus pi by 2 plus I times of sine of 2k pi minus pi by 2. Okay, this is the way of generalizing this one, and we can write as power 1 by 6, and over here we can simplify this as, if we take as a LCM, we can simplify this as 4k minus 1 pi by 2 plus I into sine of 4k minus 1 pi by 2 power 1 by 6. Okay, now if we apply the DeMoivre's theorem over here, we obtain this as, okay, we obtain this as, it is multiplied by 1 by 6. Then we can write this as cos of 4k minus 1 into pi by 2 into 1 by 6 is pi by 12 plus I sine of 4k minus 1 into what is pi by 2 into 1 by 6, it is pi by 12. Now we are applied the DeMoivre's theorem over here. So we can write this simply as, okay, now I'm going here, this can be simply write as cis of, okay, cis of 2k, sorry 4k, here it is 4k, cis of 4k minus 1 pi by 12 is our required values, where k is equals to 0 to n minus 1, that means n is equals to 6, 0, 1, 2, 3, 4, 5. Okay, if we substitute the k is equals to 0 to 5, then we'll get the required values of minus I power 1 by 6. Then the values are cis 4k minus 1 into pi by 2. The values of minus I power 1 by 6 are cis of 4k minus 1 into pi by 12, where k is equals to 0 to 5. And the next question is 1 plus I times of 2 by 3. Okay, actually it is in the 1 by n, z power 1 by n, but we are obtaining this as 1 plus I power 2 by 3, but here n is equals to 3 only. So we can write this as 1 plus I whole square into 1 by n, 1 by 3. That means here n is equals to 3, and we can write, first we have to represent 1 plus I in the polar form. Directly I am writing it as r is equals to square root of a square plus b square. That means root 2 into cos imaginary cos of tan inverse of imaginary by 1, that means cos pi by 4, it is in the first quadrant only, cos pi by 4 plus I sine pi by 4 power s power 2 by 3. Now we can write this is as root 2 power 2 by 3, okay, into, now we can write this as generalized, cos pi by 4 can be generalized as cos 2k pi plus pi by 4 plus I times of sine of 2k pi plus pi by 4 power 2 by 3. Okay, this is the way of generalization. Now we can write this as square root 2. 2 power 1 by 2 into 2 by 3 can be written as 2 power 1 by 3. And this can be written as, I am writing cos theta plus I sin theta can be written as cis of, okay, cis of it is can be written as 8k plus 1 into pi by 4. Okay, 8k plus 1 into pi by 4 power 2 by 3. Now we can apply the DeMoivre's theorem over here. Cos theta plus I sin theta whole power p by q. Then we can write it as cos theta into p by q plus I sin theta into p by q. Then we can write this as cos of 8k plus 1 into pi by 4 into 2 by 3. Okay, so that means we can write over here it is 2 by 3 into cis of, okay, cis of 8k plus 1 times of, and here we obtain this is as pi by 6. Okay, cis of 8k plus 1 into pi by 6, where k values has to be taken from n is equals to 3 here 0 1 2. Okay, 0 1 2, here n is equals to 3. Then here we obtain this k is equals to 0 1 2. Okay, then what is the values of 1 plus I whole power 2 by 3? It is 2 power 1 by 3 into cis of 8k plus 1 pi by 6, where k is equals to 0 1 2 are the values of 1 plus I 2 power 1 plus I power 2 by 3. Now how to solve the fourth one, minus 16 power 1 by 4. So now first of all we have to know what it is. Minus 16 power 1 by 4 has to be finded. So first we will represent the minus 16. So minus 16 can be written as 16 into minus 1. Okay, 16 into minus 1. So the minus 1 can be written as minus 1 plus I times of 0. Okay, is it clear? It can be written in the complex form as minus 1 plus I times of 0. That means r is equals to 1, and next theta equals to s pi, cos pi is minus 1. Then we can write this is as 16 into cos pi as minus 1 plus I times of sin pi. Okay, in the polar form the principal argument is in the minus pi to plus pi, then it is plus pi cos pi plus I sin pi. So now we can write this is as, and we can generalize this as, okay, directly I am generalizing this for our requirement, cos of 2k pi plus pi plus I times of sine of 2k pi plus pi. Okay, is it clear? Now what we have to find out, minus 16 power 1 by 4. So now the 16, this is our minus 16, this is totally our minus 16. Now the minus 16 can be a 16 into means 2 power 4 into cos of, can I take this is as 2k plus 1 into pi plus I times of sine of 2k plus 1, 2k pi plus pi can be written as 2k pi plus pi power, okay, this total power 1 by 4. Now if we apply the DeMoivre's theorem, then we can write this as 2 into, directly I am writing it as 2 into cos theta plus I sin theta can be written as cis of 2k plus 1 into pi into pi 1 by 4. So nothing but 2 into cis of, what it is, 2k plus 1 into pi by 4, where the k values are from 0 1, here n is equals to 4, 0 1 2 3. Now what is the value of minus 16 power 1 by 4? The minus 16 power 1 by 4, the values are 2 into cis 2k plus 1 pi by 4, where k is equals to 1 2 3 4. Okay, now in the similar way, now we can find if the question is given that minus 32 power 1 by 5. Okay, so directly we can write this as minus 32. That means 32 into minus 1, where 32 is 2 power 5 into, directly we can generalize cos pi plus I sin pi. That means we can generalize as cis of 2k plus 1 into pi. Okay, is it clear? So 2 power 5. So what is minus 1 can be written as cis of 2k plus 1 into pi. Okay, that is the minus 1 generalized as. Now if we apply power 1 by 5, so now apply the power 1 by 5. Then what is the value of minus 32 power 1 by 5? The values of minus 32 power 1 by 5 can be written as 2 into cis of 2k plus 1 into pi by 5. Okay, pi by 5, where k values are from 0, 1, 2, 3, 4. The values has to be k or to be taken from 0 to 4. Then we obtain it is as minus 32 power 1 by 5 as, so what it is, 2 times of cis of 2k plus 1 pi by 5. So in the next lecture we will come with a few more problems, so to solve this inequalities. Okay, to solve the what is nth root of complex numbers. Thank you.